Let us see backward difference interpolation. Then similarly in this case, if the value of the interpolating point is not provided, then this arithmetical result will convert into a polynomial, either quadratic or cubic. We will consider it later on. First of all, we check all the formulas. Second is Newton's backward difference interpolation. Newton's backward difference interpolation. It is also for the equal intervals. Then we write it, the formula for this, say f of x is equal to y0 plus p, note delta is reverse, p delta y0 p into p plus 1 divided by 2 factorial into delta 2 y0 plus p into p plus 1 p plus 2 divided by 3 factorial inverse delta y0 plus p plus 1 p plus 2 and p plus 3 divided by 4 factorial into delta 4 y0. There is no difference between the backward and difference. Just see here, we have changed only forward delta to backward delta, and all the p, they have minus signs into the plus sign. Otherwise the nature of the formula is same, but here again this property or this value of the p is very important in deciding the initial values of the interpolating data. P must lie between -1 and 0. Both are not included, they are excluded from the value of p, and again p is equal to x minus x0 divided by h. Let us consider in data the sales in a particular departmental store for last 5 sessions is given in the data, that is annual session 1974, 1976, 1978, 1980, 1982, then it is sales in millions, that is 40, 43, 48, 52 and 57. How we decide? First of all, the problem is where we apply the Newton's forward difference interpolating formula or Newton's backward interpolating formula. That the point of interpolation is helpful in deciding this. In both cases we say, or it is obvious, the interval is same, but if we say that the point of interpolation, we have to estimate, result is estimate sales for 1979. If the point of interpolation, we see where is the 1979, it is somewhere here. If the point of interpolation is in the last values of the data, then we use the backward difference interpolation. If the point of interpolation lies somewhere in between the starting values, then we apply the forward difference interpolating polynomial. Now don't think that what will happen if it is between left or right, then you can decide whichever the formula you can apply. For the value of the point of interpolation, when it is at the beginning of the data, we apply the Newton's forward difference interpolation, and when the point of interpolation is at the last values or the ending values of the given data, we follow the backward interpolation. So, first of all, we prepare the table, that is x, y. We can write these values in the vertical form. Say it is 1974, 1976, 1978, 1980 and 1982. And y, it is the sales 40, 43, 48, 52, 57. As I explained previous to this, that the construction of the interpolating data or the interpolating difference table is same as it was in the forward method. Now first of all, we find delta 1 y0. Difference is only, we use the reverse delta. Again values from below to above. 43 minus 40, that is equal to 3. 48 minus 43, 5. 52 minus 48, 4. 57 minus 2, 5. Then reverse delta y0, 5 minus 3, 2. 4 minus 5 minus 1, 5 minus 4, 1. Then delta 3 y0, minus 1 minus 2, minus 3, 1 minus 1 plus, that is equal to 2. Delta 4 y0 is equal to 5. Again the rule is same. We continue the formation of the difference table until we get at the last either a single value or it is 0 or somewhere all the values are 0. At that stage we terminate the formation of the table. Now this step is same as it was in the forward difference interpolation. Now how to decide x0 and y0? Now it is backward difference. In the forward we selected the values from the beginning, but in the backward we select the values from the last. Say it is x0 and it is y0. Now we see, does these values obey this condition? That is, again the value of p is same, x minus x0 divided by h. That is equal to, what is x? X is the point of interpolation, that is 1979 minus x0. x0 means 1982, and what is the height? We see height 2, 2, 2, 2. Height 2. That is equal to minus 3 by 2. It means that is equal to minus 1.5. It means this time the result do not obey the given property or the standard property of the P. Now we cannot consider these values at x0 and y0. Now what we do? We move to the upper pair, say it is 19, 80 and 52. Again we find the value p. There we see this value of p is rejected. Now we work for the another value of p with the same formula, x minus x0 divided by x. Here x is the point of interpolation minus x0. No, it is x0 1980 minus 1980 divided by 2, and that is equal to minus 0.5. Now we see this value is obeyed by this rule. So we start the our table from these values. Now this method is backward difference. From backward we move from below to above. That is these values, this, and we will terminate here. We will select these values. If it was this, then we would have selected this up to 5. Similarly, we follow the rules in the forward difference operator. Then it is simple. Here we see the value of p, it will come negative. But in the forward, value of p comes to be positive. That's we have changed already the formula here, p minus 1, p minus 2 to p plus 1 to p plus 2. Otherwise there is no difference in the formula except the properties of the p. We use these values in the given table. I think no, this formula is sufficient for the data provided to us. That is this f of 1979. It is the point of interpolation. It is x0 and it is y0. That is equal to 52 plus p minus 0.5 into delta 1. Delta 1 is 4 plus minus 0.5 into minus 0.5 plus 1 divided by 2. For delta 2 we consider minus 1 plus minus 0.5 into minus 0.5 plus 1 minus 0.5 plus 2 divided by 6 factorial into delta 3. Here is the delta, reverse delta, that is minus 3. No. Our requirement finishes here. So there is no need to select this step and we erase it from here. Only 3 values are sufficient for our provided data. That is, see, if we follow according to the rules, what we have seen, the calculation is reduced by 1 step. If we would have accepted these values x0 and y0, rather there is no alteration in the result permanently, but that can increase the calculations and that irrelevant calculation may result into the errors into the final results. So that is equal to 52 plus 2. That is, first of all we decide the sign, 1 minus plus minus, it is plus. Point 5 into 0.5 into 1 is equal to 0.25 divided by 2, that's equal to Here is the difference table. The nature of the difference table is same as it was in the forward difference interpolation. Only difference is we mention the reverse delta here, delta 1, delta 2, delta 3, delta 4. In the same manner, 43 minus 43, 48 minus 43, 5, 52 minus 48, 4, and 57 minus 52, that is 4. Then after constructing the difference table, we check the value for P. Here the values of P, say formula x minus x0 divided by h. We always start with the lower values in the backward difference interpolation and from the initial values from the in the forward difference operator. If we consider these two values as say x0 and y0, then according to the formula we see the value of P comes to be minus 1.5, and it does not follow the rule P lies between minus 1 and 0. So we can consider this last set of the values as initial set. So we try for this set above it, that is we take x0 is equal to 1980 and x 1979, it is the point of interpolation. Now we see the value of P is minus 0.5. No, it obeys the rule P lies between minus 1 and 0. So we select this second last pair as the initial values x0, y0, and the remaining values in the same manner trail is this, and it will finish at this. It has reduced our calculation by one step. 1, 2, 3, and 4. We have no need to write the further term. Secondly, the accuracy of the result will increase in this manner. If we put all the values of from the given data, say y0, it is 52, we have started from here, it is 52, P minus 0.5, inverse delta y1. For inverse delta we select this value 4. Then for delta 2 we select minus 1, and for delta 3 we select minus 3. No need to move further, and we put all these values here into the given formula and then calculate it in this way. That is, say, first of all sign it is minus, plus, minus, again the result is positive. We can calculate it 0.5 into 0.5 into 1.5 into 3, that is equal to this divided by 6, and that's equal to 0.1875. That is equal to that is 54.0625. It is the sales for the period 1979 for the firm according to the given data. Now in this way we apply the forward difference and the backward difference to the given data, keeping in mind first point the height of the data is same. It means the interval is same, h is same. Then second point, if the point of interpolation lies in the initial values of the data, we follow the rules of forward difference interpolation, and if the point of interpolation lies at the end of the data, we follow the rules for the backward difference interpolation. That is the only difference. Now again in this case, if x is not provided, it means point of interpolation is not provided, these calculations they will be converted into the polynomial, maybe quadratic or maybe a cubic according to the given values. Now up to this, any question, any problem, you want to ask anything, viewers? And one advice is from my side is the paper we are studying, until or unless you will not make the calculations with your hand, they will create every time problem for you, because there is no scope of error anywhere. Any mistakes depending upon the algebra or the arithmetic is not accepted at all at this level. So make the calculation, try the calculations as much hard as you can, otherwise they will create the problem for you. That the given data that was provided, I write it here in this way. See, the problem was the sales in a particular department store for the last 5 annual sessions was given like this. It is here 1974, 1970, 1976, 1978, 1980 and 1982, and the sales was in millions in this way: 40, 43, 48, 52, and here it was 57. It was the data provided, and the requirement was find the estimated sale for 1979. 1979, it is the point of interpolation. Let us see, 1979 lies at the end of the data. It means we will follow the rules of the backward interpolation. If the point of interpolation lies at the beginning of the data, we follow the rules of the forward difference interpolation. Now here we follow the rules of the Newton's backward difference interpolation, because first point interval height is same, or the point of interpolation is at the end of the data. That we use this formula for the backward interpolation. Only the difference in the P from minus we have changed into the plus, and the forward delta into the backward delta, and we can extend this formula. Now it is the table. We first of all find the difference table for the data in the same manner as we calculated into the forward difference interpolation. Now for finding the value of P, or finding the initial values, from where should we start our values? We consider the lowest values from the data for the backward, and in the forward we consider the uppermost values. But these values which we are considering, they must obey the condition of the P. This one, first we check for the last values 82 and 57. We see the P is minus 1.5, and it does not follow this value. If it does not follow, then we have rejected it. If we have rejected it, then we move to the upper pair, that is 1980 and 52. Then we see this value is minus 0.5, and we see it follows the rule. Now we start our counting from x0 from here and y0 from here, and our trail moves in this way from below to above, as it was moving in the forward from above to below. This trail finishes at -3, and we discontinue. It means this value is no use of for the further calculation. It had reduced the load of the calculations in the given formula. We have written the formula, then put all the values, and it is simple arithmetic. We can find the point of interpolation. It means here the sales for this firm was in 1979 was approximately 54.0625 millions. Any question regarding the interpolation we discussed? In the next session we shall continue. We will see how we will convert these data into the polynomials. Okay, thanks and good day.